Alright, in this video we're going to practice finding the exact value of this trig expression. So the first thing I need to do is take this this angle that is not a special angle, and I'm going to split it up into two angles that are special angles. So the way I like to do that is by subtraction. So I'm going to start with this 13 pi over 12. And I'm going to try subtracting pi over 4, but if that doesn't work, I'll subtract something else. So of course I would need like denominator, so I would multiply by 3. Now if I do that, I've got 13 pi over 12 minus 3 pi over 12, so that's going to give me 10 pi over 12. So that's going to reduce down to 5 pi over 6. So this is looking good since pi over 6 is one of our special angles. So now I've got 13 pi over 12 minus pi over 4 is equal to 5 pi over 6. Adding pi over 4 to both sides, that gives me 13 pi over 12 is equal to pi over 4 plus 5 pi over 6. So for the rest of the problem, I'm going to look at this as the tangent of pi over 4 plus 5 pi over 6. Okay, let me just erase this part. Alright, now I'm going to use my sum formulas to split this up. Alright, so the tangent of a sum, I'm going to use this formula right here. So this is going to become the tangent of pi over 4 plus the tangent of 5 pi over 6 all over 1 minus tangent pi over 4 tangent 5 pi over 6. So the tangent of pi over 4 is 1. And let's see, the tangent of 5 pi over 6. Forget the 5 for a second. The tangent of pi over 6 is radical 3 over 3. So the only question is it actually negative radical 3 over 3? So I'm thinking about the quadrant that 5 pi over 6 would be in. And when I think about my pi over 6's, I know they kind of look like this. Okay, so 5 pi over 6 is right here in the second quadrant, and tangent is negative in the second quadrant. Okay, so instead of positive radical 3 over 3, I'm going to go ahead and erase that and put minus radical 3 over 3 because it's negative. Okay, and meanwhile in the denominator, well, tangent of pi over 4 is 1, so I can kind of throw that out. And then we've already discussed that tangent of 5 pi over 6 is negative radical 3 over 3. So that would be like having, okay, so I would have 1 minus negative radical 3 over 3. But that's silly. Minus and negative is addition, so I'm just going to go ahead and put negative 1 plus radical 3 over 3. Now I need like denominators to add and subtract. So I'm going to actually replace these 1's with 3 over 3's. So this would actually be 3 over 3 minus radical 3 over 3 and 3 over 3 plus radical 3 over 3. Okay, so that's going to give me 3 minus radical 3 over 3 divided by 3 plus radical 3 over 3. All right, so what now? Let's multiply by the reciprocal. So this is going to be the same thing as 3 minus radical 3 over 3 times, no, I don't need to do that. I'm supposed to say, oh look, the denominators are the same, so they're just going to cancel out. So now I have 3 minus radical 3 over 3 plus radical 3. And that will be the final answer. Number 8, first I'm going to do that little calculation off to the side so I can figure out exactly how to break down negative 5 pi over 12. And my strategy is to subtract pi over 4 and see what I get. To have like denominators, I need to multiply by 3. Negative 5 pi minus 3 pi is negative 8 pi over 12. Now I'm going to rewrite this equation reducing the two fractions that I can. So that's negative 5 pi over 12 minus pi over 3, pi over 4 is equal to, both of these are divisible by 4, so that's going to be negative 2 pi over 3. Adding pi over 4 to both sides, I get negative 5 pi over 12 equals pi over 4 minus 2 pi over 3. So now I can just make that substitution, okay, because negative 5 pi over 12 equals this difference. So I can rewrite the original problem as cosine of pi over 4 minus 2 pi over 3. And the cosine difference formula goes cosine cosine plus sine sine. So that's what I'm going to do. Cosine pi over 4 cosine 2 pi over 3 plus sine pi over 4 sine 2 pi over 3. Cosine of pi over 4, that is radical 2 over 2. Cosine of 2 pi over 3. Well, the reference angle is pi over 3, so let's start with that. The cosine of pi over 3 is 1/2. So it's just a matter of, will it be positive 1/2 or negative 1/2? Well, 2 pi over 3, okay, is right here in the second quadrant. Cosine is negative over there because it's an x value, it's to the left. So negative 1/2 it is. Sine of pi over 4 is radical 2 over 2. Memorize that. Sine of 2 pi over 3. Well, the reference angle is pi over 3. And the sine of pi over 3 is radical 3 over 2. It's just a matter of will it be positive or negative. Well, again, it's in the second quadrant. So sine is positive up there because it's a y value. So I will just leave this as positive radical 3 over 2. So this is going to give me negative radical 2 over 4 plus radical 6 over 4. All right, which I will probably write as radical 6 minus radical 2 over 4. For problem number 9, the directions are switching up a little bit. Now we're just simplifying. We're not evaluating. We're not finding an exact answer. So the angle here is negative 6 theta and 5 theta. Okay, this is not subtraction right here. This is the sine of negative 6 theta and 5 theta. See how it goes cosine, cosine, sine, sine? That is how the cosine formula works. Do I have those formulas? No. So the cosine formula says if I have the cosine of, let's say if I have the cosine of A plus B, then that's going to become the cosine of A times the cosine of B minus the sine of A times the sine of B. See how this fits the pattern? It's just that everywhere you see an A, you see a negative 6 theta. Everywhere you see a B, you see a 5 theta. Okay, so that tells me that if I want to put it back into this shorter form, A is the negative 6 theta, and B is the 5 theta. Okay, 6 theta plus 5 theta, that's negative 1 theta, or negative theta. And I suppose we can just leave that as the final answer. Number 10 is the exact same thing, except for angle A is 5V and angle B is 3V. And there it is again, 5V and 3V. So this must be the cosine of 5V minus 3V, because for cosine, if it starts off as subtraction, then it becomes addition. So these are opposites. Anyway, this simplifies down to the cosine of 2V. And that is as far as we can go. For problem number 11, I notice that it goes sine cosine plus cosine sine. So that is the way the sine sum formula works. So for example, if I have the sine of A plus B, then that would equal sine A cosine B plus cosine A sine B. See how it matches the same pattern? It's just a matter of what's A and what's B. Well, A is 2x, all right, because that's where A goes. B is negative 5x. And then you just see it repeated again here. Cosine of A, sine of B. So I should be able to write this as the sine of a sum. So this would be the same thing as the sine of, and like we said, A is 2x, and B is negative 5x. So it's like 2x plus negative 5x. So that's just going to be the sine of, and this is really just 2 minus 5, so this is going to be negative 3x. And that's all we can do. This problem is the same thing, sine, cosine, cosine, sine. That reminds me of the sine formula. So this is like angle A, and this is angle B. And there's angle A again, and here's angle B again. So this can be rewritten as the sine of negative 2 theta plus 4 theta. Okay? And this simplifies down to the sine of 2 theta. Well, number 13 is clearly just the tangent formula, where the two angles involved are 4x and 3x. So this is the same thing as having the tangent of 4x minus 3x. And of course you can simplify that, and then you will get tangent of x. And that's the final answer. All right, again, number 14, easy peasy. This is again the tangent formula, where the two angles are negative 3x and negative 4x. So this is going to be the tangent of negative 3x plus, all right, it's always going to go by this right here, so plus negative 4x. Well, that's just going to be the tangent of negative 7x. And that's all we can do with that. So final answer. Cosine, cosine minus sine, sine. That is the cosine formula, where the two angles involved are 5 theta and 5 theta. That's a little weird. Anyway, so this will just be the cosine of 5 theta plus 5 theta. Remember that cosine changes the sign. So if this starts off as subtraction, then it will become addition. Anyway, this will simplify down to the cosine of 10 theta. And that's all we can do with that. So that's the final answer. And for number 16, we are back to tangent one more time, where the two angles involved are negative 4v and v. So this will be the tangent of negative 4v plus v. So if I simplify this, that will be the tangent of negative 3v. And that's all we can do with that. So that is the final answer. For number 17, the directions switch up a little bit. Now they're asking us to find the exact value of the expression. So we're still going to simplify, but we're going to take the additional step and evaluate. So cosine, cosine, sine, sine. This is clearly the cosine formula happening, and the two angles involved are this and this. Hold on, my little circle jumped. Can't have that. All right, these are the two angles involved. Remember that cosine does the opposite operation. So if this is addition, then when I rewrite it, it's going to be subtraction. So it'll be cosine of 31 pi over 9 minus 61 pi over 36. Now these do not have like denominators, so I really need to fix that by multiplying by 4. So this is going to be 124 pi over 36 minus 61 pi over 36. So that's going to be cosine of 63 pi over 36. Now this can be reduced. Both of these are divisible by 9. So that's going to give me the cosine of 7 pi over 4. Now that's a special angle, so we should be able to handle that. Of course, the reference angle is pi over 4. So that means that the cosine of 7 pi over 4 is either going to be radical 2 over 2 or negative radical 2 over 2. It's either positive or negative. It just depends on the quadrant. Now, so what quadrant is 7 pi over 4 going to be? Well, if you think about it, 8 pi over 4 would be all the way back around to 2 pi. So 7 pi over 4 is going to be 1 short of that. So 7 pi over 4 will definitely be in the fourth quadrant. And cosine is positive over here because it's to the right. So that's why the answer is going to be positive radical 2 over 2. And number 18 is clearly the tangent formula being used, where we have these two angles involved. And this will be a subtraction problem. So this will be the same thing as the tangent of 13 pi over 18 minus pi over 18. But that's going to be the same thing as the tangent of 12 pi over 18. Both of these are divisible by 6. So this will be the same thing as tangent of 2 pi over 3. Now the reference angle is pi over 3. So when I think about what's the tangent of pi over 3, that's radical 3. Now that's just a reference angle. The tangent of 2 pi over 3, I have to ask myself, is this going to be positive radical 3 or will it be negative radical 3? It'll be one of those. And it depends on the quadrant. So just think about what quadrant 2 pi over 3 is going to be in. Alright, 2 pi over 3 is right here. That's the second quadrant. Tangent is negative in the second quadrant. So that's why I'm going to put negative radical 3. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.